Yes. I'm sorry, I just didn't hear. Not going to do 7. You're not responsible for 7. Okay, so 5 and 6 is what we're going to do on this page right there. No, no, I'm not going to put one. I'm on the exam. I'm going to put one like number. I'm going to put one like number 1 or 2. The perimeter problem. I'm going to put one like number 3 or 4, which is just the add up the stuff problem. Then I'm going to put one like 5 or 6. Okay, that's the ones I'm gonna. Do you need another one of these from last time? Bring that. Yeah. Take it. Souvenir. There you go. All right. So yeah, that's the way it's gonna be. All right. So here goes. We're gonna do example 5 right now. This is an important problem. Told you last time that there's one of these on the final exam, so you'll see it then. So I gotta make sure I cover it. I want you prepared. So example 5. Called a mixture problem. We're going to attack this mixture problem by using our system of equations that we've been using for all of our other word problems. So let's read this together. Again, if you're watching on video, this is a PDF. Go ahead and print it. It's the section 3.3 example problems. And this is example 5 on that page. So it says, how many ounces each of a 5% hydrochloric acid solution and a 20% hydrochloric acid solution must be combined to get 10 ounces of a solution that's 12.5%. So you work in a lab, you're mixing some stuff up, okay, or you're working in, if you're a nurse, if you work in the medical department, if you're going to be a pharmacist, whatever your future has, something like this might come your way. We need to mix 2 things together to create a new mixture. Now, before we do this problem, I just want to remind us real quick about how percents work so that we understand how we're going to make these 2 equations. So let's pretend after class, you're going to go to the grocery store, okay, and you're really thirsty, so you're going to get a bottle of grape juice, because why not? Grape juice is amazing. Okay, so grape juice. And just to keep the numbers nice and round, we're going to say that your grape juice bottle, when you look at how much juice there is, we're going to say that it is, let's just go 100 ounces. 100 ounces of juice. And as you're walking up to the cash register with your nice cold 100 ounces of grape juice and you're so thirsty, you see this on the package. It says that it is 25% juice. So that means that 25% of the content is juice, the rest is whatever else they put in these things. So here's my question to you, and my purpose in this question is, this is how percents work. If you have 100 ounces of liquid, and you're told that 25% of it is juice, how can you figure out how many ounces are actually juice, and the rest is sugar and whatever else they put in? How do you use a percent? How do you figure this out? How did you get that? It's 25 to 400. Okay, so you're doing that because I made some nice, really round numbers, and you're totally 100% right on that. But in general, because we're going to be working in this example we just saw, we're going to be working with the number 12.5% and the number 5%. I want to make sure we can do this with any values. Yes. Yes. Okay, we're going to multiply 2 things together. We're going to multiply what 2 things together to figure out how many ounces are actually juice ounces. Okay, 25% now. This is the key. 25%. What number do I use? There you go. Remember, we never use percents the way they are. Percents represent a ratio. It's 25 out of 100. Okay, which is what you were alluding to, and you were 100% correct. So we use the decimal 0.25. Percents never stand alone. If you have a 25% off coupon, it has no value until you actually buy something, and it's 25% off of something. And so we take the 0.25 times the 100 ounces, and that gives us that 25 ounces of your volume is juice. That's how percents work. Okay. I don't have time to do a whole review of percents. Okay, if you've never seen a percent before in your life, email me or talk to me after class. I got some videos I can shoot your way about how to set up the ratio, how to use them. But I just wanted to remind you, because now in this problem, what we're asked to do is this. We start in our lab, we have two vials. We have a vial that has 5% acid. We have a vial that's 20% acid. And we want to combine them together to make a mixture that's in between, 12.5%. Okay, so for whatever application we're doing, we need this specific percentage. Okay, so what we're going to do is this. I'm going to draw 3 boxes to represent things that I have. This is how I like to do mixture problems. We will talk about mixture problems again in college algebra, and I will do this same thing if you decide that you're going to take college algebra with me. Okay, and again, I know most of you never want to see me again. I totally understand it. I feel the same way about myself sometimes. Okay, so here we go. We've got these boxes. So it says how many ounces each. So here's my big question. Do we know how much of the 5% acid I need to add? Do we know how much of the 25%? Are we given those values? What are the first words to the sentence? How many, right? So we're looking for these things, right? We're looking for how much of this do I add to how much of this. So since I don't know, what I'm going to do is I'm going to call the how much, I'm going to call it X. So this is how much liquid. So I've got X ounces here. We're using ounces, right? Yes. And I've got Y ounces here. I don't know. I'm just the mad scientist. I'm combining stuff into my beaker or whatever, Bunsen burner or whatever. I don't remember chemistry. It was too long ago. How much liquid do I want to have at the end? The problem does tell us that. How many ounces is going to be my result? 10 ounces. Perfect. 10 ounces. So when I combine however much of my first stuff plus however much of my second stuff, at the very end of this, it says we want to obtain 10 ounces of a 12.5% solution. Okay, so that's how much liquid. There's 2 things I don't know. Our system of equations we've been doing and we've been learning how to use have 2 equations, so I need another one. So the second equation, the reason I did the juice example just a minute ago that I just erased, is if that's how much total liquid I want to have, what I also want to know is how much acid do I have? Okay, you might not have had chemistry, or maybe you had it a long time ago. The way acids or alcohols work in chemistry is that they're mostly water. Okay, and there's a little bit of acid in mostly water. Okay, so I want to know if I have a box, I don't know how big this box is, but I know 5% of it is acid. So I'm just going to make, this is how much acid is in the box right here. That's the 5%. I want to know how much is that? Well, we're going to do what we just did with the grape juice. I'm going to say, okay, 5% is 0.05. And then percents never stand alone. It's 0.05 of the volume of the box, which is X. And however much that is. And then right here, if 20%, this is my box, this represents the amount of acid. But again, acid is acid molecules mixed around, they're swimming around inside water. And so I want to know if this is 20% acid. So this is how much acid's in this box. So I want to know what's the volume of that. Well, again, just like with the juice, we take the 20% and we make that 0.20 of the volume of the whole box, which is Y. And then over here, I've got 10 ounces. We know that this box is 10 ounces big. It's 12.5% acid. So somewhere in between these 2 lines. So right here, that's how much acid's in this box. So again, acid is acid molecules swimming around in the water. what's the volume of this? Well, it's going to be 0.125. You always move the decimal 2 places to the left, times 10, the volume. We can figure that one out. And that gives us the information for our 2 equations to solve this mixture problem. Okay? The first equation is how much liquid total? Well, I have the first thing, x, plus the second thing, y, should be equal to 10 ounces. So however much of the first liquid I add plus however much of the second liquid I add should be equal to 10 ounces. That's the total liquid. The second equation is my how much acid. The amount of acid the first one puts in, which is 0.05x, plus the amount of acid the second one puts in, which is 0.20y, should be equal to the amount of acid in the last one, which 10 times 0.125, that's 1.25. My calculator told me that. And there we go. There's my system of equations that I can now solve. Now we're not going to go through the solving. I'm going to do one step for you here to make this a little easier to deal with. But again, section 3.1 is all about solving. When you get here, it's just doing what you've been doing. But I do want to give you a little hint on this. Decimals can sometimes add a little confusion. So maybe I want to get rid of my decimals. Is there something I can multiply all 3 of these terms by that's going to move my decimal 2 places so I will no longer have any decimals? 10 is a good thought, but how many decimal places is 10 going to move? It's just going to move it 1, because if you take your calculator, 0.05 times 10 is going to move the decimal here, it's going to be 0.5. 1.25 times 10, if you put that in your calculator, it's going to give you 12.5. So I need a little bit more. You're on the right track though. 100. So here's what I would recommend you do. Since you have 2 decimal places, I would multiply this whole equation by 100. And then you're going to solve this system right here. The first equation is x plus y equals 10. The second equation, use your calculator. 100 times 0.05 is 5x. 100 times 0.20 is 20y. And then 100 times 1.25 is 125. And there's your system. And you can do that either of the 2 ways we talked about. You can either solve this top equation for x or y and substitute, or you can eliminate. What I would do, if you wanna do this as part of your homework, I would multiply the top equation by -5 to get your x's to eliminate. That would be my advice on this problem. All right, so here is the last problem from section 3.3. We just talked about setting up some different types of problems. Example 6, it's a super similar problem. You've got a 15% solution, you've got a 25% solution. And you want to know how much are you going to add together to get 30 liters of an 18% solution. So please set up the 2 equations that you would use to solve that. All right, I'm going to get started on this. Check your work with mine. If you've got a question, please, before we shut down this section, I would love to hear it. So the problem says this: how many liters of a 15% solution? So this solution right here is 15% acid we're talking about again. And a 25%, so this one right here, this one's 25% acid. How many of each of those am I going to mix together to get 30 liters? So I know the total amount. I want 30 liters of an 18% solution. Now, I am not told how much either of the first two I'm adding, so I'm going to call the first one X, the second one Y. I don't know. You can call whatever your favorite letters are. Okay, mine are X and Y for whatever reason. So right away, I know my first equation. The first equation, however much I pour out of this box plus however much I pour out of this box has to equal 30. That's how much liquid total am I combining together into my bowl. The second part is, if in order to get 18%, I can't add equal amounts. There's gonna, I don't know how much. I'm gonna have to add a little more of one or a little more of the other in order to get exactly 18%. So the way we figure that out is we say, okay, this box is contributing 15% of the acid, so 0.15x. This box is contributing 25% of the acid, so 0.25y. And then the result is how much acid is their total, 0.18 times 30. So the second equation is based on this, how much acid is there. So the second equation is 0.15x plus 0.25y, and then your calculator will tell you that 0.18 times 30, is that 2.4? I'm sorry? 5.4. Thank you for being better at multiplying than me. There we go. 5.4. And again, just to get you heading in the right direction, if you are struggling with the solving of the system, the thing we talked about last class, stop by and see me. Okay? Stop by and see a tutor. Okay? You need to get there. There's going to be several problems solving systems of equations on the test that you have on Monday. Okay? I promise. Not going to be terrible problems. It'll be just like what we did in class, but you have to know how to do them. So the other thing that I would do is, if I'm going to move the decimal of all of these three terms, what should I multiply everything by? I've got 2 decimal places here, 2 here, 1 here, so I have to multiply by 100 again. It has to be the same thing. It can't be 100 or 110. I know we only need to move that one, but it has to be the same thing you multiply everything by. So 100. So your 2 equations that you hopefully are staring at are x plus y equals 30. And then the second one, 100 times 0.15 is 15x. Your calculator can tell you that. 100 times 0.25 is 25y. Your calculator can tell you that. And 100 times 5.4 is 540. And there's your 2 equations. You're ready to solve. It's all nice and set up.